Hello, today we're going to be talking about slope. And before we get into slope, I want to talk to you about rate of change. So I have an example here. A car travels 100 miles in 2 hours. What is the rate of change? Now we see the word rate, and we should think of the word ratio. A ratio is just a fraction. So we're going to create a fraction to represent the rate of change for this car. So we have two things going on here. We have the number of hours and we have the number of miles. And between those two things, which would be independent? Well, of course, it would be hours. This will be my x value because time is always independent and the independent variable goes on the x-axis. So that means 100 miles should be the y variable. So if I were to graph this situation, what I'm looking at is 2 hours and 100 miles. If I put, let's say, I don't know, here's 2, 4, 6, 8, and then on the y-axis I can go, let's say 50, 100, 150, 200, and so on. So at 2 hours, we've gone 100 miles. At 4 hours, if we kept up the same pace, we would be at 200. At 6, we would be at 400 or 300, and so on. Okay? If we went 0 hours, we'd be at 0. And so we have this line going on, depending on how long we actually drive. So the question, though, is what is the rate of change? Well, I'm sure many of you realize that we're trying to do miles per hour is really what we're trying to figure out here. And that's going to be our rate, the number of miles over the number of hours. So in our situation, we have 100 miles in 2 hours. And there's my ratio, 100 to 2. And I can simplify that certainly to 50, and that is in miles per hour. Miles per hour. So look at how this is represented on our graph. Every time we go over 2, we go up 100. Or every time we go over 1, we go up 50. So I can go over 2 and up 100, or I can go over 1 and up 50. It's the same thing. And because it's a line, it will be the same rate of change the entire rest of the way. So that brings us to slope. So slope is the same thing as the rate of change. And when we want to find slope, we did it a couple different ways on the previous slide. We showed that we could take just the y value, the number of miles in that case, over the x value, the number of hours. We also looked at the graph and determined how much we went up, and that was our 100, compared to how much we went over on that line, which was our x. And so the slope, or the rate of change, is the same as the rise of the graph's interval divided by the run. So many times you'll see it written as simply just rise over run. Well, we can use these coordinates to create an equation. And just below the graph you can see how we use the letter m to represent slope. And we have 2 points, x1, y1, and x2, y2. So how do we figure out how much we went up? Well, up and down is the y values. So if I started down here, we traveled up from y1 up to y2. And so which one is bigger, y1 or y2? Well, because the y2 is higher, it must be the bigger one. So how far did we go up? Well, we want to find the difference in where y1 is sitting compared to where y2 is sitting. So we'll take the bigger y2 and subtract off y1 over. And then we're talking about how much we went from left to right. And we started at x1 and went over to x2. Well, what's the difference there? If we started at x1 and moved over, that's going to be your x2 take away where you started at x1. So where you ended up minus where you started. And that's our big equation for slope. So y2 minus y1 over x2 minus x1 when you have these 2 points. Let's put this into practice. So in number 1, to find the slope of this line, we have 2 points given to us. Down here, this is 0, negative 2, and up here we have 1, 3. We want to find the slope. So just like before, we're going to figure out how much did we go up and how much then did we go over. Well, if we started down at negative 2 to go up to 3, we have to count 1, 2, 3, 4, 5 spaces. So we went up 5 units. To go from 0 to 1 over, we went 1 unit. So if we're looking as slope as rise over run, we're talking a rise of 5 and a run of 1. And of course we can simplify that to say that our slope is 5. On the second one, we have 2 points, so we want to use our equation, our y2 minus y1 over x2 minus x1. And so it's really up to us what we want to consider y2 and y1. Let's make this first ordered pair x1, y1. We'll make this ordered pair x2, y2. And we want to plug these numbers in to this equation. So y2 is 8 minus y1, that's 7. There it is. And y2 is 8, and you can see that there. Over x2. x2 are these numbers, so x2 is 6 minus x1 is 1. And we just do the evaluation. 8 minus 7 is 1. 6 minus 1 is 5. And so our slope is 1/5. And we are done.